My name is Ondřej. I would like to introduce you our EKAW 2024 demo paper submission. I'm from Prague University of Economics and Business, and we did this work within Ontology project, which aims to support the distributed management of information about the flow of entities such as materials and products. We will apply ontology transformation on BPO ontology. This is building product ontology. We will look at it in a second, and we will also apply transformation pattern class by attribute type pattern. So BPO ontology is ontology which has a circular economy domain, and we can see that it focuses on how different product components can be assembled. You can see the class assembly, element, components, the parts of assembly, and there is also product. We can check it in the protege, where we see the assembly is a subclass of component, but assembly as such does not have any subclasses. We will use transformation pattern. So transformation pattern enables us to transform ontology. For example, if we have one modeling style, we can change the modeling style to another one, and our transformation pattern, more information is provided within the demo paper, and our transformation patterns are serialized within JSON. So this is one example of transformation pattern. The transformation pattern generally consists of three parts: ontology pattern source, source ontology pattern target, and naming transformation part. So the first part, source ontology pattern, it contains triples, which enables us to detect the pattern instances, which are then transformed into according to target ontology pattern. So we can see that there is some object property which has a certain domain and range, and range is superclass of some another class C. And in a target ontology pattern, we can see that there are the same triples, which means that they can be kept within new transformed ontology, but there are some new triples. For example, that G is subclass of A. A was initially a domain of ontology property B within the ontology, and there is some restriction which is constructed based on information from the previous triples. And actually the G is newly added entity. We will see example in the presentation. And there is also naming transformation part, which has now two elements, lex. This is about providing information for naming. For example, we are working on using large language models. So there is some information how, for example, large language model or human could, which information could use to name newly added entity G. And there is NTP, which stands for naming transformation pattern. This is actually template-based instruction how to create labels for newly generated entities, in this case G. So we can use more instructions. There are in all three of them, and what I forgot to say is that there are some, you can see some naming operations like label. It means that we will take, the tool will take label from A, a label from P, and there are some other ones which are also described within the demo paper. So we should go back to the presentation. We described the motivation use case, which is about rule mining in circular economy domain, and this is described within the demo paper. I would like to say that rule mining task in this case is over data which corresponds to BPO ontology and some other interlinked ontologies, and we can have some possible output rule, for example, that we can find, the process can find that an assembly contains, that if an assembly contains dynamic entity, and we consider dynamic entity as some multiple components, undistinguished among each other, which then they could be reused in its parts. So this is basically the rule, but the mining process can be limited to the certain length of antecedent, for example to 2, and then it could not be possible to that the mining process could not find this rule. Of course, there are some solutions directly from the data mining field. For example, it could be we could use feature construction. Then we could have some newly added feature, and the rule could be found. But this solution lacks reusability. Probably there could also not be proper naming, and it would also lack documentation how this was really done. So we could also use another solution, in this case ontology transformation, and we will see this in the example in the next slides. So we already saw CAD transformation pattern. This is its graphical depiction, and CAD stands for class by attribute type, and we can see here maybe better that in fact as a result this pattern leads to regeneration, new hierarchy based on some existing one. So this corresponds to source ontology pattern, as we saw before, and so we can see the object property P, which has domain and range, and there is also in range B, which has some subclass of C, subclass C. We can also specify within the transformation pattern conditions, in this case using filter, that A and B should not be the same, because otherwise it would not make sense to generate the hierarchy. And this is actually this is already the situation where we use the target ontology pattern. So then the subclass G is generated as a new subclass of A, and in detail there are also some there's also some restriction which we can see in the notation on the slide. So let's look at the naming aspect. The naming aspect for naming transformation pattern. So these are the instructions how to name not directly G, but its label. We can use more options, many different labels can be created. We can see it also in a minute within the tool itself. So the first one is that the label, there are also used naming operations, that the label of A, then it is concatenated with the another label using the string and etc. So let's look at the example. For example, we can use CMT ontology, which is from the conference organization domain, and we can apply this transformation pattern. So we can already see one pattern instance. Object property has decision, which has in its domain paper, and in its range there is decision, and the acceptance is subclass of decision. So the G, this is the newly generated entity, and we can check what is the result of applying the template-based instructions for the label. So the first one, it is the paper that has decision acceptance. It's not completely okay, but it's not bad. It's quite good. Then we can see another one, the passivize, which is concatenated with the head noun of A, and the result is accepted paper. Actually, these naming operations working on the fragment of array, because there is not specified. We can also use the label within the naming operations passivize and head noun. So actually this should try to make passive form of some word, but yeah, it was fine, accepted actually. And this one, it should take the main term of the word, which is paper, and then there is also one. There's just only one word, so it's not difficult. So accepted paper sounds good, and the last one is very similar to the first one. So this is the example, and so now we can have a look on the building product ontology and the solution for our rule mining use case. So if we apply cat transformation pattern on BPO, one pattern instance could be this one, or is this one. There is composed of entity object property, which has domain assembly and range entity, and dynamic entity is subclass of entity. And based on this, we can create new subclass or subclasses. Depends on how many pattern instances we can find and we can select from the ontology. So we can generate some new subclasses using this transformation pattern. So here are some naming instructions again. So the first one, and the result is the label would be assembly that is composed of entity. This is rather clumsy, but not very bad, but not also very good one. So we can check the another one, dynamic entity assembly. Maybe sounds better, but actually it's not passivized because it was working on dynamic entity and it was just default probably, and head noun of A is again assembly, but it could be better than the first one, and the last one is actually very similar to the first one. So as a result, we have new G entity, which is subclass of assembly, and this is actually something new which we didn't have before in the BPO ontology. And we can return to our rule mining use case, where we already showed that there is the result that if the mining process is limited to a certain length of antecedent, then this could be solution, because applying this transformation pattern, we can get assembly new entity which is subclass of assembly, and that's something that resembles to the previous longer version, longer structure, but this is not very nicely named. So we think that this could be renamed either by human, or, as I said, we are already experimenting with using large language models for naming. So this is probably the result of better naming assembly with dynamic entity, which is in antecedent. And there are some online resources. The tool itself, we will check it in a second. The screencast, which is available, and the code is available on GitHub, and the documentation for the REST API. So let's go to the tool. So this is the tool on this address, and the basic functionalities are the load ontology, and on transformation pattern. We can see pattern matches. And here are different information that leading to GitHub and the documentation, etc., and the changes. So let's start with the load. There are already some transformation examples. You can just click on it, and you can see the pattern matches, and then you can continue. But we will upload it by ourselves. There are two options: load from files from your drive or from disk, or you can use URL. So we will use URL because we already opened the ontology here, the BPO ontology, and you can just copy the link into the PatOMat ontology URL, and we also have some transformation pattern here. This is the very same example as is prepared already here. Then we can click on the load button, which means that it applies the process, the detection process. Actually, the part source ontology pattern is applied on the ontology, as this is described within the EKAW demo paper that is actually SPARQL. And then we can see here the output. First, there are some statistics. You can apply more transformation pattern at once, which could be really useful because you can have different variants of one basic transformation pattern. So then you can just apply it at once, all of them, and then you can see statistics, and also you can you can see the results of all of them, and you can select in which those that you are interested in. So these are the statistics, and there are actual results, the pattern name, pattern instance, matching bindings. So there are first the name of variables and also its entity. And then this column, it consists transformation SPARQL, which means that it's actual the instruction what will be applied on ontology based on transformation pattern. So we can see delete part and insert data part. So this is actually SPARQL update, and this is generated according to transformation pattern. I will look at the example from the presentation. So it should be it's composed of entity. It's this one. So I will check it because I want to apply it on ontology, and we can see we should see the very same content as before. So if you want, you can also apply the delete, but because, as I described before, the transformation pattern doesn't lead actually to delete any axioms. If you repeat it, then you can really be safe, then there will be nothing deleted, which is better maybe in some situations. And you can always decide about the deletion. Here you can apply transformation, apply only inserts if you want to be safe and not delete anything, because maybe you forgot to, or the transformation pattern engineer forgot to repeat the triples. Or you can apply deletes and inserts, so it means the full transformation SPARQL here. I will return to the pattern instance. So we can see that this is the object property is composed of entity with its domain, assembly, and the entity in its range. And dynamic entity is the subclass, actual subclass of entity. So this is the right-hand side, what we saw on the presentation on the right-hand side. And we will regenerate this taxonomy using the new entity. This is randomly generated, the URL, the fragment of array, and this is subclass of assembly. And there is also the restriction as described before. So we check it, and there is one more column which is about the naming of new entity. This is the G entity. We can see this randomly generated array, fragment of array, and here are the naming of label for G, which are based on instructions from transformation pattern, as we saw before. And we can select just only some of them. By default, all of them were selected. So I think that this one is quite good. So we will apply this label. We can also edit it, but I leave it as it is. And we can, for example, use it as a pref label, save, and then the other ones should be set up as an alternative. So I will check it. We could also improve it a bit. Assembly is composed of dynamic entity, save, and then that's all for me. So I will apply these changes. So apply transformation. We can apply deletes and inserts because it's repeated. And what happened is that the ontology is actually really transformed. We will check it in a sec. And there is also transformation summary, which summarized a number of new entities and edit statements. So you can see that there's a pref label, dynamic entity assembly. Then there is also the triple about subclass. The newly generated class is a subclass. And there is also alt label assembly that is composed of dynamic entity, and also it's the restrictions of newly generated class are added. So what remains is that we want to really check newly generated entity. So it should be, and this is this has been, let me check it. This is BPO, just only BPO. So BPO, it should be this one, I think. No, maybe I will. Maybe this could help. Yeah. Okay. So we will expand all, and we can really see that there is newly generated entity as a subclass rendered by its label, but maybe I should select also its pref. Okay, so dynamic entity assembly. So that's what we really wanted. I mean, we can also see that there is out label, assembly is composed of dynamic entity, but that's the result. And that's all. So thank you for your attention, and I hope that we will see each other at a conference, and you can check the tool there, or you can check it by yourself from the web. So okay, thank you, bye.